Hi everyone, this video is about geometric sequence focusing on finding geometric means. Let me show you how to derive formula in finding the common ratio R whose a sub 1 is one of the given two non-consecutive terms. A sub n equals a sub 1 r raised to n minus 1. That is the nth term or general rule for any geometric sequence where a sub 1 and r are not equal to 0. By dividing both sides of the equation, we have a sub n over a sub 1 equals r raised to n minus 1. The goal here is to find r. So we need to isolate r on one side of the equation. So it should be r raised to 1 or just r. So we're gonna get the n minus 1 root of both sides of the equation. That gives us n minus 1 root of a sub n over a sub 1 equals n minus 1 root of r raised to n minus 1. That gives us n minus 1 root of a sub n over a sub 1 equals r. By symmetric property, then r is equal to n minus 1 root of a sub n over a sub 1, where r refers to the common ratio, n refers to the position of a term, a sub n or the nth term, and a sub 1 of course is the first term. Let's have example number 1. In finding the geometric mean between any two positive numbers, say a and b, it is the square root of their product. So therefore, there are two sets of geometric mean, one positive and one negative geometric mean of a and b. Insert a geometric mean between 3 and 48. The given are 3 blank 48. There are three terms where 3 is the first term, a sub 3 is 48, and the geometric mean is a sub 2. We have two solutions for this example. Step 1, solve for r using the derived formula. R is equal to n minus 1 root of a sub n over a sub 1. N is 3 because there are three terms. That is, r is equal to 3 minus 1 root of a sub 3 over a sub 1. Substituting, r is equal to square root of 48 over 3. Thus, r is positive and negative 4. If the root is even, there are two possible roots. We have positive and a negative root. That means also that there are two sets of geometric mean. Okay, step 2. Solve for a sub 2 when r is 4. That is 3, first term times r, 3 times 4 is 12. When r is negative 4, multiply the first term and r, we have 3 times negative 4 is negative 12. So we can say that the possible geometric mean is 12 when r is 4 and negative 12 when r is negative 4. Solution 2 for number 1. Solve for a sub 2 using the square root of the product of a sub 1 and a sub 3. That is, a sub 2 equals square root of a sub 1 times a sub 3. So that is a sub 2 equals square root of 3 times 48. Therefore, a sub 2 is positive and negative 12. Number 2, insert a geometric mean between 54 and 24. There are 3 terms. First term is a sub 1, which is 54. Last term, or a sub 3, is 24. The geometric mean is a sub 2. So let's find a sub 2 by using the derived formula for r. R is equal to n minus 1 root of a sub n over a sub 1. That is, r is equal to 3 minus 1, because there are 3 terms here. 3 minus 1 root of a sub 3 over a sub 1. So we have r is equal to square root of 24 over 54. Then r is equal to positive negative 4 over 9. Step 2, solve for a sub 2. So when r is 4 over 9, or the positive 4 over 9, multiply the first term and r. 54 times 4 over 9 is 36. When r is negative 4 over 9, multiply the first term and r. 54 times negative 4 over 9, that is negative 36. Okay, so therefore, the geometric mean is positive negative 36. Solution 2 for example number 2. Solve for a sub 2, or the geometric mean, using the square root of the product of the first term and the last term, or the third term. So that is, a sub 2 equals square root of a sub 1 times a sub 3 equals square root of 54 times 24. You can extract the factors. If you don't have a scientific calculator, so you can manually compute it. We have square root of 9 times 6. 9 times 6 is 54. Factors of 24 is 4 times 6. Therefore, a sub 2 is positive negative 36. Number 3, insert 3 geometric means between negative 2 and negative 32. There are 3, 4, 5 terms in all. First term is negative 2. Last term, or a sub 5, is negative 32, and the geometric means are a sub 2, a sub 3, and a sub 4. Step 1, solve for r using the derived formula for r. R is equal to n minus 1 root of a sub n over a sub 1. N here is 5 because a sub 5 is in the fifth term. Of course, we have 5 minus 1 root of a sub 5 over a sub 1. Then we have r equals 5 minus 1 is 4. Fourth root of negative 32 over 2 is r is equal to positive negative 2. Take note that if the root is uneven, there are two possible roots, a positive and a negative root. So step 2, solve for the three geometric means. Let's start with r equals 2 multiply first term and the root that is equal to 2. Negative 2 times 2 is negative 4. Negative 4 times positive 2 is negative 8. Negative 8 times 2 is negative 16. To check, let us continue. Negative 16 times 2 is negative 32. So our r is correct. Okay, when r is negative 2, again multiply the first term and the r. So that is positive 4, and then multiply again. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Okay, so these are the possible sets of geometric means if r is positive and negative 2. Okay. Example number 4. Insert two geometric means between 1/3 and 72. There are 4 terms in which a sub 1 is 1/3 and a sub 4 is 72. The geometric means are a sub 2 and a sub 3. Step 1, solve for r. R is equal to n minus 1 root of a sub n and over a sub 1. R is equal to 4 minus 1. There are 4 terms and the fourth is a sub 4, which is 72. Substituting, we have r is equal to third or cube root rather of 72 over 1/3 is 6. If the root is an odd, there is only one root. It's either positive or negative. Okay, now it depends on the radicand. Alright, so step 2, solve for the two geometric means. By multiplying the first term and the root, 1/3 times 6 is 2. Then 2 times 6 is 12. 12 times 6 to check, we have 72. Okay, number 5. Insert 4 geometric means between negative 3 and 96. So there are 6 terms in all. First term is negative 3 and the last term is a sub 6, which is 96. Geometric means are a sub 2, which is the first geometric mean, a sub 3 is the second geometric mean, a sub 4 is the third geometric mean, a sub 5 is the fourth geometric mean. Again, step 1, solve for r. R is equal to n minus 1 root of a sub n over a sub 1. N here is 6 because we have 6 terms and the sixth term is 96. Substituted to the formula, we have r is equal to fifth root of 96 over negative 3 equals r is equal to negative 2. Okay, as I have mentioned on the previous example, if the root is an odd, there is only one value of r. It's either positive or negative. Now, depending on the resulting quotient of the radicand. So this one is negative. Step 2, let's compute for the 4 geometric means. Multiply the first term and the r. Negative 3 times negative 2 is 6. 6 times negative 2 is 12. Negative 12. Negative 12 times negative 2 is positive 24. 24 times negative 2 is negative 48. To check, negative 48 times negative 2 is positive 96. That's it.